So what do you guys put down here for the claim? The mean debt is less than 906. Where's that go? The high. So what's the hoe going to be? How many tail tests? Because there's a direction, right? That's the. I like it. I kind of gave this away earlier, right? What says I can do something? Beautiful. And then, of course, we already mentioned that sigma is unknown. So then I have to use unknown. It's unknown. So I have to use t-scores. So now if I go down here, n is 81, so the degrees of freedom is 80. Alpha is 0.01, and it's a one-tailed test. I got everything I need. The only extra thing I need for a t-score is to know where to stop. Z-score, I don't have to do this because it go all the way to the bottom. So now I know to stop at 80, so I've got a 0.01, one tail, 0.01, stop at 80. So hopefully you guys got, yes? What's that?
How is sigma
Oh, what is it? We know it. What is it?
well, how is it
What's the only standard deviation that we do know is this one that we got from a sample. That one is the only one we know, and it's the sample standard deviation. It's S. So do we know sigma? No. You could also say right here, S is the only one we know or something, right? But it's just quicker to say sigma unknown. Yeah, only know S. Yeah, I like it. So coming back, I'm sorry. What was the t-score? Which side is the tail on? Down here. And what do I put here then?
2.37.
Not quite. It was 374, right? But that's not right.
It's negative.
Negative. Yeah. So this is, this is a dumb little piece of paper. We're the humans. We got the brains. We got to know if it's positive or negative just based on where it is. So don't be putting something down there and making it positive. That don't make no sense. As much sense as my grammar makes. But oh well. Good thing I teach that. Right there. Less than. So where's the sample got to show up to show evidence for that? Down. Yeah, so that's beautiful about this. Whatever the high says is it's pointing you in the direction. Not equal to, of course, is bonus. So how do I say this in words then? If T star is less than that, we can do what? If I get in here, we can do what? Reject the hoe. Support the high. So this is just statistics. This part of statistics is our attempt to quantify what enough evidence is, and then seeing if we found enough evidence. So now down here, what do we know? We know X bar. Let's start with that because I always forget that. What's X bar? 880, 34. Don't forget them 34 cents. S is what? So what's the new S? 106.25 divided by square root of 81. Anybody confused about why we got to do that? I could be wrong. I could have a insane moment.
Just because I thought you would do that to find the sample, the new sample standard.
So we got to be careful. It's the only reason you think it's sample is because it's the one that is for the sample means. right? So that's what this means, standard deviation for sample means. So that's opposed to standard deviation for individuals, which is what this is. I don't care if that's an S or a sigma, it is for individuals. I always have to do this to make it for groups of whatever. I like it. That's why I really try to harp on individuals versus groups. And then whatever the hell that is. It's almost 12. So it's 11.6, 1.8. I'm okay with that. I'm just trying to do my head so I can give myself a little. 11.8. 0. 6. Yes? And then I just make, now this formula for T is the same as for Z. Because they really are fundamentally the same thing. They measure how far away from the mean. So T star will be my data, 880.34, minus the supposed middle, 906, divided by the spread we just figured out. Yes?
Would it be the square root of 80?
No. It's the square root of n. Degrees of freedom you only use to find the t-score and then you stop using it. Yeah, the rest of it's just n. Yeah.
What's the actual formula for that?
Is it x bar minus?
All right. So the real. All right. So z star is x bar minus the mu of the x bars divided by the standard deviation of the x bars. Doesn't that look gross? But that's what it is. It's my data minus the middle divided by the spread. So T star is the same shit, but instead of sigma, I would have put a S. Same formula. They really are the same formula. So what do you guys get for this? Anybody got that?
Yeah, they do 2.17.
I like it. 2.17 roughly. Did we make it? All right, let me stop. Everybody cool with that so far? No? What happened? You don't agree with it? You're okay. All right. Did we make it far enough away? Oh, I see. You're answering the next question. So no, we didn't make it. We made it here. We didn't make it far enough away. So the guy who thinks it's in here, I didn't find evidence to say he's wrong. So what do I put here then? Fail to reject the hoe. Fail to support the high. That's all. You either reject the hoe or you don't. You either support the high or you don't. We fail. And then, of course, how do I write my conclusion? Well, which one was my claim? In this case, it was the high, so I'm going to use this language, not this language. So fail. We have not found sufficient evidence to support the claim that plagiarize. Or rewrite it, whatever, you know. And once you go on your English teacher say, well, you know, somebody else said I was capable too. We have not found sufficient evidence to support the claim that what? That the average credit card debt has decreased. Bam, that's good. So again, one more thing I want to talk about real quick, and then I'm going to let us out because you can only do so many of these before you start to lose hair. So I don't want to be the reason you all go bald. Back on this sheet, I forgot one thing. Has everybody got that? You guys got that? Sorry, what's up?
So on 8 says resource score enough.
Yes. Technically, yes. But again, it would be so evil if on a test I put a whole problem that some people are doing, wasting time, while others realize they didn't have to do it. You see what I'm saying? I could put a question that wouldn't be, don't do the test, just tell me why you couldn't do it or something. You see what I'm saying? So yeah, nothing is an option in general, but on a test or a quiz, that would be really evil for me to, some people won't notice. That would be, yes?
Would it be nothing if the standard deviation?
All right, well, some situations it would be nothing because we don't have enough information, but that's, why else would it be nothing we could do? Well, what is it that tells me I could do something?
It's normal.
If it's approximately normal. So if they don't tell me it's normal and the sample size is too small, that would be where it's officially nothing. So if you hit a problem where you think the answer is nothing, you say that, but you still do it. Because there's a good chance you're wrong. You missed something. You read over the part where it said it was normal or something, right? Okay. Yes?
Oh, no, you answered my question.
Oh. Okay. So coming back to this problem, you guys still have this, right? You didn't rumple it up and throw it away. Did it catch your time? This p-value thing. This is really, really important. So all the p-value, oh good, I have space here. All the p-value is, so real quick, on this problem here, it was 2.326 for the rejection region, right? Right.
Yeah.
Where's alpha on that picture? Where's alpha on this? Where is it? Well, where is it?
Oh, at the top.
Up here, right? That's the area in the tail. Alpha's 0.01.
So that's
Alpha is the area in the tail of the critical z-score. The p-value is the area in the tail of my z-score. What was our z-score in this problem? 3.45. What is the area in the tail of 3.45? Oh shit, nobody's looking. This is an old problem. This is chapter 6 problem. Don't say it out loud yet. Find out for me what the area in the tail of a z-score of 3.45. What's the area above that? What's the area in that guy's tail? This is an old question. So you should be looking at your z-score charts, and you should be looking at what? Probably. Yes. That doesn't sound quite right. Let's see. So 3.45, if I heard you right, 3.45 is 0.9997, but that's not the area of the tail. It's the area of the tail. 1 minus that, so that would be 0.0003. What the p-value is a probability that you got that sample, but the middle is in the right place. Is that p-value big? 0.0003. That's 0.03%. Is that big? If there is a 0.03% chance that you're going to live till tomorrow, you're going to feel good about that. No. Thanks, Jeff. That was really morbid, but too bad. Right? Of course that's not good. That's bad. That's way small. But in this case, that means that is damn good evidence. That is the probability that sample would show up if the middle was in the right place. Remember, what did we do with this problem? We found evidence that the mean was bigger, right? And that kind of jives. That is so unlikely that what's more likely is the mean actually is bigger. But what's beautiful is there's always this chance that we're wrong. Why is that beautiful? Because that's frickin' life. Math ain't magic. People discount statistics because they can't tell you for sure what's going to happen. That is insane. It can only tell you, it looks like it's good. Yeah, give or take. All right, so let me, yes.
What if it was on the other side, but just was rejected?
No, of course not. Yeah. So the tail is above, that's why I got to subtract 1. If everything was happening on that side, I wouldn't subtract 1. I like it. Now, so again, alpha is the area of the tail of the critical z-score. P-value is the area of the tail of my z-score. Yeah, your z-score.
Why did we find it for this problem but not the other one?
It's just because we didn't. So, I was gonna, all right, we can do this right now. I was gonna save this for tomorrow, but where's that other problem? Shoot. Here, this one here, right? So on this problem we just did with the Ford Focus, we could find this p-value. The difference on this problem was, how many tail tests is this? So then whatever I get for the area in -262, I'm gonna have to double it. That's the only difference for a 2-tail test. Because alpha was put across 2 tails. To make it fair, I've got to kind of double this guy. So if I look up -262, I get an area of 0.0044, so this guy's p-value would be 0.0088. Still the area in the tails, it's 2 tails test, so I got to double it to be fair to compare it. So, last thing. In real life, kids, real talk, you're not going to see an alpha in any journal article. Why do we do it in here? Because alpha is based on somebody's own internal understanding of what they think enough evidence is, right? You guys don't have enough experience in the kind of shit you could read in these to know what your own alpha would be. So when you're in class, we give you alpha. That's what enough evidence is going to be. In journal articles, so this is an interesting one. If you have kids, hey kids, if you have kids, you know about too much screen time being bad, right? It's also bad for you too, but hey, you know, we're adults, we do all kinds of bad shit. Let me zoom in a little bit. So they did this study on kids. One thing I want to point out, something old, look, 95% confidence interval, kabam. But also look, P. P is 0.01. Is that decently small? So again, the smaller P is, the more evidence it is that whatever you saw is truly a difference. So in this case, children with more than 2 hours of screen time had a 7.7-fold increased risk of having ADHD. And how sure are they about that? 1% chance they're wrong. You guys semi with me? That's still not like a full technical explanation of P, but it's good enough to be able to interpret what this article is saying. The P-value is so misinterpreted, but we know what the hell it means. Notice also it's got like P equal to 0.05. For me, that's not enough evidence, personally. So I would want to see more of their data for whatever the hell that was. Because 0.05 is 5 times bigger than 0.01. For me, it's not enough evidence. But for somebody else, it might be good enough, right? Somebody else down the road is like, 0.1 sounds good to me. It's because you suck. Anyway, so that's why when you're learning it, we give you alpha. When you have enough information, if you're going to be a nurse, or if you're going to be working in business, or you're going to work in something where you got to look at articles and understand, you can have your own internalized sense of what enough evidence is. That's why they only give p-values. Okay, maybe. So now what I'm saying is you can go find a journal article about something you like that has some kind of evidence for something, and you could actually understand a decent amount of it. Is my hope. All right, that's enough for today. So don't forget, next time, I did say, remind you guys, quiz next time, right? I'm going to have the formulas on the quiz, you know, have to have a formula sheet.
Is it just chapter 8?
Just chapter 8, confidence intervals.
So the next is like the next corrections for the last test, or
They're due on the day of the next test, and this is a quiz.